Hi lads, in this video I'm going to go through how to 2009 higher level question 4. It tells us the elevation and plan of the sand bucket and beach ball are shown. A 3D graphic of the bucket and ball is also shown. The bucket and ball consist of a truncated inverted cone A and a sphere B respectively. The sphere rests on the horizontal plane and is in contact with the truncated cone. The bucket has a semicircular handle S positioned as shown in plan and elevation. Part A. Draw the given elevation and plan, showing all constructions and points of contact. Part B. Draw the development of the conical surface A. And Part C. Draw the development of the semicircular handle S. So to start off this question, I'm going to draw the elevation and plan of the bucket and ball side by side. So the first thing to do is draw in the position and plan of my cone and sphere. So the first thing I do is I draw my XY line. I'm going to keep this question to the right hand side of the page. So I'm going to draw my axis going down through the centre of the cone. Now you can see from the question that the cone has a height of 70 first. I'm just going to put that in. And the radius is a radius 35 for the outer half, and the lower half is going to be a radius. Well, it isn't given the radius for that there, so I have to figure it out by drawing 75-degree angles first. So first of all then, I'm going to draw my radius 35. And just draw that in. So there's my radius 35. And I can take these extreme edges up to give me the top of the bucket, there and there. And then I'm told it's going to be an angle of 75 degrees then going down to the base. Just get my protractor and I measure my 75 degrees. And connect that together, there to there. And what I can do is save me measuring the 75 on the other side. I can take that distance and step it across the opposite side there, and then connect those two together, and that gives me my elevation of my bucket. I can then take that width down and that width down there, and now draw the inside of the bucket. So the focus, as you see it, there's the inside of my bucket there. Now the handle is positioned at a 45-degree angle. And in the question you can see it appeared as if it was semi-elliptical there in the elevation. So what you need to do is, you need to take your point up. There's one end, and there's the other end. What we want to do is imagine that the bucket handle is actually level. So what we do is we take our radius and we apply it as if our handle was facing normally like that, as if our handle was running from there to there. But what's happened is it's been rotated around. So it's been rotated around there and rotate it around there. So it's been twisted from this way to this way. So what we want to do is, we've already moved 2 points. You can imagine we've rotated this point around to here. I'll just call that 1. And rotate this point around here. And let's just say we take a few more, say 2, 3, 4, 5, 6, 7. And just say that's point 8 then. We've rotated point 8 around there and got point 8 here. What we need to do with the rest of the points is repeat the process. Rotate them around as if they were in their original position. So for example, if I take point 2 here, rotate it around into position. There's point 2 there rotated around. Just put point 2 there, 1 there as well. And what I'm going to do is take 2 up as if it was to hit the handle as normal. Just focus that there so you can see. And what we're going to do is take it across. That'll go as far across as where it is in its rotated position. That gives me point 2 there. After that, I repeat the process for points 3, 4, 5, 6, 7 and 8. So 3, rotate 3 around. Take it up to hit the surface there. Take 3 across. And 3 is now positioned here. We then have 4. Let's label these as we go along. So there's 3, there's 2, 4 rotates around there, 4 is taken up, it's taken up here as well, and I take 4 across to that point there. Point 5 is going to be the very top one. So point 5, I'll just go through the very central axis all the way up to the top. Height that won't change. 5 is up to there. Excuse me. And then you'll have point 6, 7, 8, and sorry, I've changed that one to 9 because 5 is going to be the center point. So point 9 is the one on the outside here. So because these points are rotated up here and these ones were rotated down, I rotate these around. So 8, for example, on the opposite end. 8 will go up to there and across, and 8 will go there, and then I'll repeat the exact same for 7, 6 and 5. Or sorry, just 7 and 6. So 7 and 6, I just take them all up in one go. 7 goes up to there, 6 goes up to there, and take them across. 7 there, 6 there, and 7 is going to give me that point there, and 6 is going to give me this point here. And what that will allow me to do then is draw that semi-elliptical shape there that appears for the handle, as the handle is actually twisted around. And there's the handle now drawn in my elevation. So it's a little bit tricky, and just to show for anyone who wants to see in colour, I can just put that in as well. Just put in an example of one of the points. Just put in number 2 for example. So 2 is my point there. I'm taking 2 up hit my semicircle in elevation. It comes across, and where it hits my line at 45 degrees after rotating it around, that goes up then. And that gives me my point there each time. So a bit of work in it. After that, then I'm now going to get ready to draw my sphere beside it, so the actual beach ball. I'm told the size of the beach ball is radius 30 and it's positioned in front here somewhere. So the first thing you need to do is actually draw in your sphere as if it's touching the edge. You want to find a point of contact of this line on its side, and then we can rotate it into position. So to find where it's positioned on its side, we want to find a point which is going to be the centre of the sphere that's going to be 30 mil away from the ground and 30 mil away from this side here. So the easiest way to do that is get your set square and take a line up. And we're going to draw a line that is going to be parallel to this line here, and it's going to always be 30 mil away. So somewhere along that line, after taking that 30 mil up because that's the radius, somewhere along that line is going to be the centre of the circle, or sorry, the sphere. You need to repeat the process on this side. I'm just going to take a line out perpendicular, and I'm going to take that 30 mil as well. And when I go parallel to this side, I'm going to be drawing a line that's always going to be 30 mil away from that edge there. And we're then to cross. There's the centre point of my sphere. If I drop a line down, it's going to be the point of contact with the ground. And then if I go perpendicular to the centre, from here, that's going to be the point of contact along the edge. So that point of contact will never change with the side of this going the whole way around. If I just keep rolling that sphere around and around that, the height of that point of contact will never change, as the sphere is always in contact with the ground as well. And now I draw in my sphere, and it's sitting alongside it. So it's not in the correct position yet, it's only been rolled around to the side. I've only drawn this on the side so I can see the point of contact as an edge view. That centre can be taken down, and you don't have to draw this into the exam, but just to show you, this is the position of what it would look like if it was to be side by side. But we know in the question that needs to rotate around to be in contact with the 45 degree line here. We can see in the question the line extends out to show where the centre is. And it's important now to actually rotate that around as a result as well. So we take our centre, we rotate it around, and that will give us the centre of our sphere in the correct position. Take our radius there, and because it's fitting in underneath, the inside here is going to be hidden detail, and then the rest of it will be drawn in heavy as a result. That's going to be there, and then the last thing we do is we take our centre up here, height never changes, there's the new centre, and we can now draw in our sphere in its new position in elevation. And this will be all heavy as it's sitting in front of the actual bucket as well. So we're going to have our line run down here. It's going to be dashed behind this all the way, and then it appears heavy again there. That'll go across, and that'll be in heavy there. And the last thing is our points of contact. So we know that our point of contact always lies along the centre of two circles when joined. So somewhere along that line is going to be our point of contact. When we had it in contact with our edge, that was our point of contact. Remember our normal going perpendicular to it. Our tangent line there, that's our point of contact. When it was in the side view position, so what we do is we take that down and we rotate that line around then. And the point of contact is given as this point here. So what I'll do is I'll show that in colour because it's very hard to see with all these lines. So there was the point of contact when it was on its edge. I dropped it down like that. I rotated it around. There's my point of contact there. And what you do is you take that straight up. You take the height of your point of contact across, and that gives us then our actual point of contact between the two there. So I'm just showing that. I take my arrows down around this way, that's the way I find it, and then finally this one goes back up here, and that gives me my point of contact there between the two. And that completes our elevation and our plan of the actual questions. That's part A done. Part B is draw the development of the conical surface A. So the actual bucket part here, excluding the handle for now. So because it's based on a conical surface, it's going to be a cone. So to find the actual apex of the cone, we extend our extrusion generators. And that'll give us this length here. So an extrusion generator is always going to be a true length. So if that's a true length, we can use the true length to find our development, because our developments are always based on true lengths and true shapes. And what you can do is somewhere out here, for example, you've got here on your page, I'm going to take a line out at a random angle, just like that there. And I'm just going to swing it around like that there. So that's a true length of my extrusion generator, so that's going to be one side. Remember, we divide cones up into 12 equal parts. So to find the length of one side, I can divide one of my sides of my cone here. So there's the base of the cone. So there's this circle here on the outside and plan. The distance from here to here is going to be one length on my cone. So I can take that distance there on my compass. I'm going to swing that a number of times around to give me the full base of it. So to make sure I count them out correctly, I'll just dot them around the outside for the rest of the way as to where all my points are going to go. And then after that, I'll just label them as well. So I'm just going to go from here, and I'm going to start on the side here with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm going to go from 0 all the way around to 0 with this distance marked off. And that will complete the outer part here, so the part's going all the way around. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, and then finally 11 back to 0. And just mark them out. So 0, 1, 2, 3. So 0 will eventually connect back to 0. Now what I need to do is connect the ends together. So you can see there that would be the development of the cone if it wasn't cut. But the problem is the cone is actually cut off. The top of the cone is cut off at this point here. So what I need to do is take the distance from here to here, because that's my extreme generator, it's going to be a true length. So I'm going to take that distance there and swing that around. And all I'm focused on now is this part here. That's the development of my actual truncated cone where it's cut off. So that can go in heavy there. Extend it out to here. That goes heavy all the way out to there. And now what I need to do is draw my fold lines. So each point is going to be connected back. The difference is fold lines are only going to go between here and here, but everything still connects back to your original point, the apex. And then finally the last one here. Now I'll just draw my two ends in heavy there as well. And that's the development now complete for the question. So part C then is the development of the handle. So the development of a handle is very, very simple. It's basically you have a semicircle and you just want to roll that out flat. So remember the original idea how the semicircle drawn straight on? It's that line there, except in the view we have is just twisted around. It's the exact same idea. We draw our semicircle, we plot out our points, so divide them into 36s and then just stretch them out. So I'll just do that here. I'll just take a line there on the page, you can see that there, and I'll take my radius that I used in the original question, just dot my center point here, and I'll just draw a semicircle there. So what I want to do is divide up that semicircle into a number of equal parts. I could also use these distances here because they're the exact same, just to show you it's been done again. Write them 30 there, 6 up this way. I'll do is just count them as 0, 1, 2, 3, 4, 5 and 6, and I'll just show with this one the line will be taking this distance here in pink, and that focuses. Just rest that there. I'm going to draw a line across, because remember the handle is only going to be a straight line. There's point 3 already. All I need to do now is step out these distances, which are the exact same all the time. 3 will step out to 2, 1, 0, and 3 will also step out, 4, 5, and 6. I'll just show with the colour once again. There's that distance there between 0 and 1 is the exact same. And I'll show with orange here that the distance between 0 and 1 is repeated all the time between these 2 points here. And I'll just draw this line in then heavy. And that completes the question then. So part A was drawing our elevation and plan, showing our sphere in the correct position, showing our point of contact. Part B was drawing our conical surface, rolled out flat. And part C was then drawing the handle, rolled out flat as well, the development of that. If anyone has any questions, please message me on Teams, and I hope that video helped anybody who was stuck.